Hello, I'm Michael Liebreich, and this is Cleaning Up. As everyone knows, battery prices are plummeting and manufacturing volumes are soaring, whether for EVs or for grid-connected storage. And everyone knows there's a problem. Only 5% of lithium-ion batteries are recycled. The rest go to landfill. Right? Wrong. My guest today on Cleaning Up is the world's preeminent expert on battery recycling. Eric Melin is the founder and managing director of Circular Energy Storage. Please join me as we hear about what is and what isn't happening in battery recycling. Before we get started, if you're enjoying Cleaning Up, please make sure that you like episodes, subscribe on YouTube or your favorite podcast platform, and leave a review. That really helps other people to find us. Please recommend Cleaning Up to your friends and colleagues and sign up for our free newsletter at cleaninguppod.substack.com. That's cleaninguppod.substack.com. Cleaning Up is brought to you by the Liebreich Foundation, the Gilardini Foundation, and Ecopragma Capital. Hans-Eric, thank you so much for joining us here on Cleaning Up today.
No, thank you very much for having me.
Let's get stuck straight into the content, right? You're the battery recycling expert. We'll come to why and how you got here. But I just want to start with this famous statistic. Only 5% of lithium-ion batteries are recycled, right? Everybody says it, so it must be true. Is it true?
No, of course not. It's not.
It's not true. Okay.
No.
And what's your best guess of today, what percentage of batteries that reach the end of their life are actually lithium-ion are being recycled?
Well, I think it's definitely 90%, can be more.
So already it's at 90%. So everybody out there thinks it's 5. The right answer is 90. Yes. Right? And there are probably all sorts of caveats, and we're going to dive into the detail.
Definitely,
right?
yes.
Okay, so with that out of the way, what your bio, right? How did you get to be the expert on battery recycling? Where did all of this start?
Yeah, I mean, it didn't start maybe where you can imagine it to start. I don't have a background in engineering or chemistry. I'm actually in communication, but that is also what brought me to where I am today and what I'm doing today. So I spent about 15 years in battery reuse and battery recycling, and before that, around 10 years in renewable energy, and also recycling of different kind of materials. The reason was really that I was very interested in to understand what changes people's behaviors, what makes them use new kind of technology. So, in the early 2000s, that brought me into biofuels or solar, both heating and electricity. But in 2008, I became CEO for a company that made sorting equipment where we used AI to sort batteries.
AI in 2008. Wow.
Yeah, we did. Yeah, we did.
Amazing pioneer. I bet you wished you'd stayed with the AI and forget the sorting, right?
Yeah, sometimes, maybe. But I mean, we found an application. We found an application that batteries needed to be sorted because you have all these different chemistries of batteries. And we also sorted electronics. And that is really where we started.
Is this using vision? So using machine vision as we...
Yeah. We used primarily vision. We could recognize over 3,000 different kind of batteries. And we sorted 15 batteries per second. It's like 2 machine guns.
Wow.
I think the biggest problem was that there were not enough batteries to sort.
Not enough battery. We're going to hear a bit more about that, I suspect.
Right, yes.
So you've got this business that is doing AI for battery sorting for the recycling.
Yep.
And that was, 2008? So we're talking about whatever that 16 years ago. So
right. Yeah, absolutely. And but in 2015, it brought me to America, to one of our customers. So I was heading market development for battery solutions, which today is part of a company called Cerba Solutions, which is one of the biggest recyclers. At that time, I think we were definitely the biggest collector and one of the biggest battery recyclers in the US, doing all kinds of chemistries of batteries. And that is really where I recognized or realized that I was doing so much in terms of data collection and analysis, and that we also did not know very much. We knew basically what we had, what our competitors had in terms of volumes, but we did not know what is not here. What do we not get, and why do we not get it? And that was really the foundation for Circular Energy Storage, which is a company I'm running today, where it's really about to understand what is happening with the batteries from the point when they are placed in the application, and from in terms of reuse and recycling.
And so, just to be clear,
yeah.
Circular Energy Storage is not doing storage; it's doing information, data.
Yes, yeah, and that might be some misunderstanding sometimes. Often it's quite good, actually, because we get a lot of information because people think we are in energy storage. But
so,
yes,
I know that feeling because I started something called New Energy Finance,
right? Yes.
Which of course is not a finance provider; it's an information provider. Now Bloomberg New Energy Finance. I can't tell you how many people called or emailed and said, they're after finance. I'm the guy with the finance.
Yeah, right.
And it's very hard to stop people talking in that situation.
Yeah, no, absolutely. And I mean, the idea is really to use data to make batteries and, in fact, energy storage more circular, because there is so much, information as such in your value chain, from, as I said, from the point you place it on the market and then through the whole lifetime. What kind of information and data you have there, that will be very important for the circularity as such. And that has always been the vision for what we are providing. And
so the data and information you provide, can I characterize it as, I'm guessing similar to what I did with New Energy Finance? I didn't see myself as an advocate. I just thought if people had better information, they'll probably do more of what I was covering, because it's kind of makes sense.
Yeah, obviously, I think for anyone that is very deeply involved in something, it's both important and difficult to draw that line sometime. Of course, I think I'm more of an advocate for electrification and for the use of batteries than what many others would be. Or, there are people that are less advocates than what I am. So, of course, there is some bias in that sense. But I think it's what what we pride ourselves about is really to do very granular data. To really, go the last mile to understand really what is behind this, and then you obviously also have to be prepared to be wrong sometimes, right? So yes, we are not advocates. We are not pushing an agenda in that sense, but obviously we see things that we also try to explain.
Right, but your customers would generally be people who are already in or looking to get into recycling or financing recycling or doing something with the materials that come. So they are, in a sense, using the information positively. You're helping to support the sector by helping them to do their business. But there's a sort of there's a flip side to it, which is that the lack of recycling, the 5% only being recycled, the lack of recycling is used as a way to actually impede the rollout of electrification and battery solutions.
Yes.
So your information is then, in a way, it's going to be, it's in the detail, it may be promoted or maybe helping the industry, but it's also dispelling myths. At least that's how I see it.
Yeah. It does. But on the other hand, it can be used really in, as all kinds of information, and that is our experience. It can be used from all kinds of purposes, and I think that is also why the data is acquired. We have most of the automotive OEMs as customers, for instance. Among them, there are many that really, for them it's important to, in terms of their end-of-life strategy or even the battery strategies. There might be some that just want this information to point out that, every day that is an internal combustion day, it's a good day, right? As long as we can push that out, it's a good day.
So it's a funny thing about myth busting, right? Because your information so it helps the industry, but it also myth busts. The funny thing about myth busting, and I've done a bit of it in my time, is it's very difficult to get paid for it.
Yes, yeah, correct. And I think, and I hope we get into that in this 5%, but because there are really not many that are benefiting from it to be solved.
Right, so let's do a bit of unpaid myth busting.
Yeah, right.
The
yes.
5%. Where did the number come from? What is the history of that number, that meme that's out there?
Yeah, it has two sources. It has one of the sources is from which I call the European path, and that is from originally from a report of Friends of the Earth. They wrote a report in 2013 about. I think it was generally batteries, but battery recycling was one of the segments. And they used a press release from EBRA, which is the European Battery Recycling Association, saying that in 2010, the volumes of lithium-ion batteries had been decreasing. It's actually quite interesting. They said it was decreasing, so it was higher the year before. And that number that I don't know exactly the tonnage, whatever it was, but they were asking a recycler in Europe. So what does this mean? And they correctly said that this is about this amount of batteries. It represents basically 5% of the batteries that the prior 3 years, or the average of the prior 3 years, were placed on the market. So the 5% of the batteries that are now among the recyclers represent 5% of what has been placed or sold to the market the last 3 years. And that is how the EU, in the European Union, that is how they defining the collection rate for batteries, right?
So just to be clear, that means that in that, whatever it was, previous year, there was an amount of batteries that were recycled, which had been made some years before and happened to get to reach a recycling point. It was that piece. And then they compared it to the average of 3 years of new manufactured, which presumably at that point includes some Nissan Leafs and some some quite, I mean, you're talking about comparing a bunch of sort of phones and laptops and
yeah,
so
but
on,
no, this was actually only portable batteries, so it did not. And you wouldn't find so many Nissan Leafs in that, even if you would have included.
So it didn't even include EVs, where of course the statistic is wielded as a weapon.
No. And you know, primarily portable batteries is what you go to like Sainsbury's or to Carrefour or something, and to put your alkaline batteries in, right? So
now you said that was one route, the European route. What happened then?
Yeah, and I would just say, so what happened with this route, or this 5%, is that, so I mean, this was correct. That is maybe not the best way to describe a recycling rate, but it was correct.
Mathematically correct.
Guardian wrote an article in 2017 where they were using find this number in 4 years earlier report that was using another 4 years early information. And there they said that today it's 5%, and from there it just took off. So it's been used in hundreds of academic papers. It's happening in the really large, sophisticated research publications. They are using it as well. And then you had this other route, which I call the American route. That was from a research paper in 2016. And that was actually not 5% recycling, it was 95% landfill. So we were saying that 95% of all batteries are landfilled. And the information is not even present this is from the abstract in this paper, and it's not even present in the paper. There are a few references, and the best reference there is a reference from the collection rate of lithium-ion batteries in Taiwan in 2009. That was 18%. So it was actually better than what they wrote. And this number, this took off even more, became inverted to 5%. This is what is used by the Department of Energy in the US. And it's still, I mean, you can find reports will come out next month that will use these numbers.
It's so fascinating, and you must sort of, in a way, it must be part of your brain must be incredibly angry and frustrated that this stuff lives, and then next month there'll be more and more, it'll be repeated. But there must also be part of your brain which is really kind of, as a communications expert, isn't it fascinating that because people want to believe that there's a problem, because they don't they don't want change for whatever reason, they don't want to change their automotive technologies,
yes.
And therefore they'll grasp any number, however tenuous, that has been debunked and continue to use it. And surely by now they must realize that it's been debunked, no?
That's a very good question, because I think a lot about that. I mean, when you go home to your family and think you have been doing a good job or whatever, I mean, and tell your children, I mean, did you lie today at work? And of course, maybe all of us are doing that to some extent, but do you really deliberately put out this on a website knowing that this is not right, or in a report saying that that is not correct? And it's interesting you are referring to me as a communicator. I mean, I left the communication business because this is what I got sick of in terms of, this positioning, using of lobbying or whatever. That's something I found very exciting in the beginning, but then I found it much more compelling to work in actual business. And now I find myself back into this kind of environment where this is highly potent, because I mean, as I said, this is a great number for so many. It's a great number for all the researchers that need to show that we need a lot of research here because we don't know how to do this. It's great for startups saying that nobody has an idea of where all these batteries will, what will happen with them. It's great, obviously, for anyone in gas and fuel or in hydrogen or in lead acid batteries, showing that there is no way to recycle lithium-ion batteries. So everybody are really happy. It doesn't matter which side you're on. Everybody are happy about it.
So it's a whole ecosystem of motivated reasoning.
Yeah.
Incredible. Now, I think before we get into the 90% that you think it really is, and then presumably it's going to go up from there because of what's going on, let's dive in just a little bit, if we could, into things like collection rate, recovery rate, and so on, because there is a question around every time you see a statistic in this space, the question is, what does it actually refer to? So talk us through, if I shoot out some terms, can you sort of tell us what they are, right? What is the collection rate?
Yeah, collection rate means that the batteries out there that now are deemed end of life and then should be available for end-of-life treatment. It doesn't necessarily have to be recycling, could be reuse as well. But that number, how many of the batteries are actually make it back to some kind of professional, sorting facility, so they can be treated. And that is a number that is used primarily for portable batteries, actually. And these ratios are more targets because it has to be operational. If you would ask, a compliance scheme, a collection organization that get the assignment to collect batteries on behalf of somebody else, you have to have some kind of target, and you can't really go out and see exactly how many batteries out there. I mean, you don't have to report what you're doing with your batteries. So yeah.
So as you're speaking, I'm trying to think about how many batteries I've recycled versus how many batteries I have sitting in drawers. I've got an old Motorola flip phone. I've got the computer that I used when I was at business school. It's now over 30 years ago. I still have it. So the collection rate would essentially, I would be ruining the collection rate by just sitting with those things in my drawers. I'm reducing the collection rate, correct?
Yeah, you do. I mean, because we have the same kind of targets for electronics, where we usually find lithium-ion batteries. So that's actually something very important to point out, that most lithium-ion batteries are always contained in their devices. So they kind of live the lives of the devices. It's different for power tool batteries, for instance, because there you can actually replace them. In cameras, you were able to do that. But besides that, most people have never touched a lithium-ion battery.
So there's another myth before I get on to the next term I'm going to throw at you, but there's another myth, which is that EV batteries only last, 5 years. And so we're going to have this, huge challenge or opportunity to reuse them. But that, I don't think I've ever met anybody who's replaced the battery in their car. So what's happening is that the batteries are lasting as long as the car. And presumably what happens with internal combustion cars is they go from developed markets to less developed markets to ultimately they end up in the global south somewhere. Is that what we're starting to see already?
Absolutely. And even right in between that that you are referring to, you also have that they are migrating between different kind of users who have different kind of requirements. It can be your children, for instance. It can be the first next line of user, or it could be you sell it to your neighbor that might only need it for a local purpose or something. So, of that reason, you usually can have a car, even if the battery would not be perfect, you will have it for a long time. And actually, we do that. I don't know why you have that laptop at home, but a laptop, for instance, is a good device where you can always use it plugged in. So even if your battery is worthless, that laptop might still be in your home. So all these things in our drawers, it's actually not. First of all, I own those things in my drawers, right? It's mine. So only because EU has a target. I might have some affection, just like a jewelry or whatever.
Or you might be able to get money by selling it to somebody who has. Because I have this image that everybody's got targets for collection rate. Some people are building factories for recycling, and meanwhile, there's all these Tesla S's that are going to be sold. They'll end up as taxis in I don't know, Lagos or Delhi or somewhere where yes, they've only got a 50-mile chargeable range, but that's enough to do some business. And
yes.
They're not going to enter. They're not going to hit that collection rate.
No. And this is really the reason why we have the collection rate for lithium-ion batteries is poorer than for other batteries, than for alkaline batteries, for instance. Which is quite, it's understandable if you think about it, that you have to, in toys or whatever, where you're using alkaline batteries, you have to replace them. You might replace them already after 3 months. But a lithium-ion battery, you are not even able to remove it. Those devices...
So alkaline, you mean the kind of the non-rechargeable alkaline?
Single-use batteries.
And if you leave them in the device, of course, then chemicals start coming out. So you're much better off taking them out and taking them to this.
Definitely.
But let's go on with the terminology. Recycle. So we had collection rate. What is recycling rate?
Yeah. So if we now have collected the batteries, so of course now we wonder how much of these batteries will be actually recycled. And that is basically what so what it means, that from a volume of batteries, how that supposedly are now waste, how many of them are actually recycled? Because of course some might be tempted to not dispose of them in the way that you would like to do, but the thing is that if you have collected the batteries, which are usually very valuable, they will be recycled. So that is really the ratio in between. And this is an interesting thing with landfill, because people tend to use landfill synonymously as dumping, but landfill is actually a waste treatment. They are professional landfills, so professional landfills for hazardous waste, right? So it would technically be correct to say that we collected like 100% batteries, but we put 50% on landfill and we recycle 50%. That would still be, if that would have been correct, which is not. But what I mean is that that is what could have happened. But of course it's not happening, because that rate is very high, because it's much more beneficial to recycle them than to do something else.
And when you talk about just on the collection, there's kind of two different sorts of collection. There's the sort of supermarket or the DIY store where you can dump your old devices, and then there's the increasingly for cars, for EVs, that looks very different. That's not down at the supermarket. That's then a vehicle you'd call it a scrapyard or a end-of-life vehicle.
Car dismantlers.
Dismantlers and so on. And what you're saying is both of those, most of this stuff, once it gets there, 99%, 95%, some very high proportion, because it's valuable, is actually going to be, or is being already recycled. So that's
definitely
right.
Yes.
So that's the recycling rate. What is recycling efficiency?
Recycling efficiency is about, okay, if you now will recycle this battery, how much of the battery will in fact be recycled? How many of the materials will be turned into something that we can classify as an end product that is now recycled?
So that's a metric inside the recycling plant. That's the batteries arrive at the recycling plant and what mass at the end goes out to be reused versus really going to what I might call landfill.
Yes, definitely. I mean, take electronics, for instance, where you have gold. If you only would, which is a tiny amount, but if you would only take out that gold, obviously you would have a very low recycling efficiency. Batteries is a little bit better, or lithium-ion batteries are a little bit better spread in terms of the value of the various materials. But of course, you would be tempted, depending on what kind of process you had, to only recover a few of the elements, right? And then you will get a lower recycling efficiency.
So the recycling efficiency is to what? It's just mass. It's just, I got 10 tons. I was able to sell 9.5 tons of various materials.
It's a mass balance.
It's a mass balance.
Okay. But it's also, then you can have different definitions of what is actually recycling.
Right. So let's get to then recovery rate, right? Because now we're getting really specific as saying, okay, you've got lithium, you've got cobalt, you've got nickel, you've got, I don't know, various plastics. And then presumably, do you have a different, so the recovery rate is?
So now we go by element.
By element,
yeah.
Okay.
So how much of the nickel that was inside that battery will now be recovered? How much of that will be usable nickel in some way, I mean, as a chemical or as a metal?
And so we didn't do for recycling efficiency, so the mass of the battery, what sort of numbers are you seeing? And then we'll come on to the recovery rates. That was the same question.
Yeah, it is very different from different kind of processes and depending on where you are in the world, in fact, as well. If you look at what you need to obtain is 50% recycling efficiency by law for lithium-ion batteries. I would say maybe that is where some of the recyclers in Europe could be at, because that would be the current collectors together with the cathode material. But definitely, if they are not allowed to account some of the energy as, recovered energy or recycling, then it would be lower than that. But you can be much higher than that. But it would be difficult to obtain 100%.
Okay, but that is the recycling efficiency. That's just of the mass. So presumably they're throwing away the low value stuff. And what are the recovery rates then? When you start to talk about critical minerals, what are the recovery rates that you're seeing?
Yeah, so if we just first should take the high recycling efficiency rates, I would say we see recycling efficiency in some countries for around 70%. We're still talking about recycling efficiency. Then when it comes to recycling or recovery, recovery rates, yes. Yep. Yes, I mean, that also depends because can be a trade-off of which element you target. It can, of course, also be very different depending on what kind of market prices we'll see. But in most plants today that are doing hydrometallurgical treatment, over 90% at least, in China you actually have a requirement of 98% of the cobalt and nickel must be recycled, while it has been 80% for lithium. But most often today, lithium is also over 90%, but that can be a bit lower.
And so when you, there's one or two more of these, purity. when you recover, are you recovering something that can go straight back into the supply chain? Because that's obviously the circular. I mean, your circular energy storage, not kind of nearly circular or a bit. Right? So what sort of purity comes out at the back end of this? Can this stuff all be repurposed and go back into a new battery?
Our view is that if somebody is paying for this at market prices, then you might have a payable or a discount on what you're paying, of course. But I mean, you're not doing that for fun. So we treat prices as such as a very good indicator of what will happen with the material next. Then, of course, you have different requirements on different products or different materials. So purity is, for instance, what will say whether this is a battery-grade lithium or industrial-grade lithium. And then industrial-grade lithium means that it can go into applications where the purity rate is not as important as it would be for batteries, for instance. So that is part of the whole trade-off here when we are looking at the whole process.
Because in these kind of narrative wars, sometimes we're told, but you can't make it pure enough to use in a battery again. To which my response as an engineer is, of course you can. It's just a question of money, right?
Yes, exactly. It's a question of money, and it can also be a question of expertise, or in terms of where are you with this material? I mean, why should a particular recycling plant, why should they invest in something that makes it battery-grade material? Because you might have a lithium refinery next door that still has to increase the purity, because not virgin lithium is not pure either, right? So I mean, it's better that the recycler would trade this with somebody whose expertise it is to make it really pure.
Now, the poster child, at least in the West, for this is Redwood Materials. So that's J.B. Straubel, who was a co-founder of Tesla, and there's a lot of if you start typing in battery recycling, it won't be long until you come up with Redwood Materials, and they've done 95%. Which of those metrics have they done 95%? I mean, is that the recovery? Is that collection? Is that what is their 95%? And how special is it?
They claim that an average of the material they recover will have basically a recovery rate of 95%. So that one, yes, which basically means that they are most probably doing 99% of nickel and cobalt. They might do a bit less on manganese or on lithium. I have no idea, but I mean, an average within those like 90%. Right?
So it's not the recycling efficiency. It's not just the total mass of the batteries. It's actually the recovery rates for the key. So they're averaging their key minerals.
Yes, and I don't think it's so much to be upset about, in fact, because, I mean, if you look at it, in a battery, about 25% or 23% will be organic materials. And
casings and separators and sorts of things.
Yeah, depending on, yes, but yeah, absolutely. I mean, separator, it's a binder, is the part of the electrolyte. You have the graphite that, could potentially be recycled, but often it's not recycled. So that's why recycling efficiency usually end up in somewhere around 70%. And maybe that is not the worst thing. I mean, if it's a battery that's been like 20 years in a car, you now end up with, like it's equivalent of kind of 40 liters of petrol or something that you are burning. But that's great, isn't it? for 20 years of use.
So now, I've never been historically not been a huge fan of circularity, because I think it's an enormously sort of trendy concept, but I've found it hard to sort of see how it acts as a lodestar for a business. How do you actually make it happen? But I've been converted on a couple of things recently. One is heat circularity using industrial heat pumps, but the other is actually around exactly this, because if you mine minerals, right? And everybody says we've got to do so much mineral mining. It's either, they say it's either impossible or very, very difficult to do the transition because of mining. But all the data they're relying on ignores recycling. The life cycle assessments that everybody is using for vehicles particularly, but also for wind turbines and solar panels, says we're not going to take, it just does not take recycling into account. So I did a back of envelope a few months ago and said, well, hang on a second. If you can recover 90% of critical materials when you recycle a battery, if the technology has improved by 10% between when you last made a battery and now, then those minerals, keep on working forever.
Yeah, of course. Yes.
Which is circular, right?
Yeah, definitely. Yes. And I mean, I think it's interesting with circular economy as a buzzword or a trend. I mean, the world is already quite circular. I mean, the automotive industry, except for that it's burning petrol and diesel, it's always been, not always actually, but I mean, the last 50 years been fairly circular. And I mean, the battery industry is quite circular as well. It's just that we often want, if it's not like white people involved in a project, then we don't think it's circular.
Because a lot of the recovery happens overseas
Yeah, absolutely. I mean, it's about trade. It's about really maximizing the value for first a product, and later maybe part of a product, and eventually of a material over the whole life cycle. And I mean, not least in China, where actually many of the industry is really starting by, it's easier for them to maybe get recycled material than to get virgin material in the beginning.
So this insight of mine that, if you have, you mine your minerals, you make a battery, 15 years later, you recycle it, you lose 10%, but you make a better battery.
Yeah.
And so those minerals are essentially forever, as long as the learning beats the recovery losses. So this huge insight that I was very proud of, it's always been completely obvious to you.
Yeah, absolutely. Yes, yeah, definitely. I mean, as we were talking about, you have losses of some materials. I mean, for the world to become like 100% circular, that every hydrocarbon molecule would be always, I mean, recycle. We might not get there. But in terms of, I mean, again, that's really what's great with metals. I mean, it's a bit easier to recycle them.
So, yeah, and the figures for steel are quite extraordinary. Something like 90% of all steel that reaches end of life is captured, recovered, whatever term you want to use. And something like in the developed world, something like 70% of our new steel comes from electric arc furnace recovery of old steel. So kind of in steel, we're very far down that track. We're a lot less far down the track with lithium, cobalt, nickel, and so on. Copper, of course, we do recycle a lot.
We do recycle a lot of copper, and we do, as I say, we recycle a lot of steel. But copper is actually quite interesting to look at, because we have like recycling. I mean, I think the amount of recycled copper in terms of the actual copper production is around 30%, a bit more than that. But in many countries, like in the US, it's higher. It's like 60%. But the main volume of copper recycling is really production scrap still, which is we're also talking about in batteries. And the reason for that it's so high is, of course, that not least Europe and the US, the kind of material that we get our hands on, it's more what is from more organized flows of materials, because we are not always great in keeping the products within our domains, which is most probably right. Because otherwise there would not be so many cars, there would not be so many, types of electronics in Africa or in South America or whatever. But what's interesting with production scrap is, of course, that does not really add to anything. That's just, I mean, if you had 10% of production scrap, that will go back into that production and become 10% production scrap once again.
Yeah, no. So in a previous life, I worked on eliminating production scrap, because all it is, I mean, it's just waste, because it goes back into the same process. That's the in the best of worlds, it goes back into the same process. It just wastes resources in the process. It doesn't create new resources. No. Let's come back to this question of end of life and what does it actually mean? Let's unpick that one, because we've also got people talking about second life and reuse. So we said that a lot of these car batteries are lasting a lot longer than people thought, and it's partly partly they're lasting longer, but then, are they ending up going into second life yet? Is that real? Is that actually happening? Or are they going into recycling when they do get collected?
They definitely go into what we call, at least we can call it reuse, but definitely second life as well. So we are still only at 2024. We have had electric cars now for around 14 years. Some were a little bit earlier, like the Roadster or the IMEV, but I mean, so say 15 years.
The Think. Do you remember the Think?
Yes, absolutely.
In Norway,
yes,
the Think.
Exactly.
Ahead of its time.
Definitely, yeah. No, very well, in plastic.
Or since it's not in business anymore, perhaps it should be called the Thought.
Yeah, right. Yeah, but so I mean that's when it started, right? 2007, 2008. There we I think were made during those years. So we know that. I mean, we know what happened to those batteries, and when it comes to Tesla Roadster or Auto Nissan Leaf, which was the earliest real electric volume produced electric car, we know that most of them are still on the road. So then we can conclude that, okay, at least 15 years doesn't seem to be a big problem. Then we are approaching the kind of the average scrap rate in many countries, like 17 to 8 years. And that often have other reasons than the actual purely functional. It can be that the repairs that you are facing compared to the value of the vehicle is just too much. So the only way for you to do something is actually to scrap it. But that means that batteries will most probably be at least 15, certainly 20 years in the vehicles. So how could we even have a clue about reuse at this point when we only had 15 years of use? And that is, of course, that we have had like everything from R&D batteries to we have crashed vehicles. So I mean, from the first day you have a model on the road, you will most probably also have an end-of-life battery, which is not really an end-of-life battery. It was part of an end-of-life vehicle. And what happens with those? Those goes to car dismantlers. That's what we were talking about before. I mean, it's in a professional organization. They basically have only one job, and that is to capture as much value as possible from what they now have recovered. They, depending on which market you are on, I mean, they have to buy those wrecks. So, I mean, they are obviously assess the value of this vehicle and say, okay, what can I make from that? And they can maybe make that over a longer time, of course. One problem they have with electric vehicles is that the warranty of the battery is 8 years. So if you now have a completely new model with a completely new battery, for somebody to need that battery on a second-hand market because it would have been worn out, it will take 8 years. Because usually if there's something wrong with the battery within 8 years, it's not your fault, it's the OEMs. So they don't have so much of a market. So what you see is this is driving repurposing, that you will use this battery for something else, because otherwise they have to wait 8 years for it for something that might not happen by then as well. Because if this is then also known to be a very good battery, there might not be so many replacements. Nissan Leaf is a market where we actually do see replacements today. It has now been out there for, what is it, like 13 to 14 years. It is also a vehicle that we see has been exported to many markets like Eastern Europe. And
on that one, I understand there's a market also. The initial Nissan Leaf had a 70-mile range, but now you can put a battery into it that's got a 200-mile range. So there's a market. That's a reuse market where you can buy a used battery or a crashed car battery or something and but it's a small market, isn't it?
It is a small market, but it's also still small volumes of batteries that do come back. So they match themselves fairly well. But of course, I mean, there's a small market, not least because your Nissan Leaf now, which is 12 years old, is worth only like £4,000 to £5,000, and or I don't know, $6,000, and should you now make a replacement of a battery for 2,000? But a lot of people are actually doing that.
So there's some batteries then that are going into the sort of car dismantlers. They get a car. Sometimes I have a friend who took his Porsche Taycan to the car wash, and the car wash guys rammed it into a wall and wrote it off. And the battery, there was some insurance issues, but eventually the battery was bought for, I think, something like £40,000.
Yeah, definitely.
But that was was a couple of years ago. So some of that is going on, but there's also, and some of these batteries will go into the second life market. So they would be used, and let's come back to that bit. But they can also, the batteries, there are other pathways. I mean, it's not like everything else goes into immediately being ground up or melted down and recycled, because there's batteries, there's modules, there's packs, there's modules, there's individual cells. What's happening there?
So it's been what we have seen in so many other markets, that they are, in the beginning you have a little bit of a Wild West where everything can go anywhere, and which basically means that you have had entrepreneurs, private persons, companies out there for already 10 years that has been trying out different kind of things. So we have a lot of real second life companies that are really doing this. I mean, assessing the batteries, and they are building systems around that. I think
what sort of systems in the second life? I said we'll come back to that, but what sort of systems, just to give an idea of what sort of things are they building?
It's interesting. I mean, what everybody saw for themselves in the beginning was energy storage systems, and I would say that is usually what we have.
Home energy, grid connected, what sort?
There are everything. There are grid connected, there are on the behind the meter, in front of the meter, commercial, residential. You have energy storage for like car or from EV charging. So all kinds of application you have in energy storage, you would also have in second life energy storage. And this was kind of the initial story about this, because if you remember, I mean, of course you do, because 10 years ago, the prices were so high of lithium-ion batteries, so there was a doubt that energy storage as a business would really take off. And I think that is where the initial idea came, that, okay, yeah, but we can use these old EV batteries. But during that time, we did not see so many EV batteries, but we saw the prices of the lithium-ion battery coming down.
I was always skeptical, because to me it felt like to believe that a second-use car battery was going to be connected to the grid, it was a bit like saying, well, my old laptop will go into a server farm. And of course, if you build a server farm, you buy servers, you buy NVIDIA chips, you buy a very specific sort of thing. Yeah. What you don't want is a whole bunch of a couple of hundred old Nissan Leaf batteries and some Teslas and a couple of Taycans and a Miev and a whole bunch of BYDs. And then you've got to somehow figure out how to use all of that. Am I wrong, or was I wrong in that thinking?
No, you were primarily right, I would say. And if we looked at already back in 2014 and 15, the companies that were doing second life, the first, it was some of the car makers, but it was in fact also some of these really early, both residential and commercial industrial energy storage companies. And they came basically to the conclusion, as you say. But there are various reasons for it. It's not only that it's difficult to assess a battery, it's something that many have paid attention to. It's also that there were not so many batteries. I think Nissan Leaf was a great example, because there you had, over a couple of years in the US, you had a huge amounts of replacements for warranty replacements. So there was a need for those batteries to go out. So suddenly everybody thought, okay, now the wave is coming. Now all the batteries is coming towards us, right? But then it basically dried out. But then you had a lot of companies that were building systems around that. But what's interesting is that you can't only look at it from your point of view, because if you look at it from that, you're an energy storage company. You want to, you have a revenue stack, you have software and everything that what you have to pay attention to. You don't want these kind of scrap batteries. So you might not be in the target group. Just like somebody walking on Bond Street and so who can buy, all these expensive clothes? I would not do that. Doesn't mean that there is nobody else that can do that, because I remain here with my battery. So if you don't want it, fine. But there is still a battery.
So what you're saying is that the price, therefore, will kind of, in that situation, the price would drop until somebody will say, well, I can use that.
And the interesting thing is that the price is usually too high to be used in energy storage because of various reasons. Because some of these batteries might be used in other completely different kind of applications. And early applications, not least for Tesla Model S, which was really for a long time, that was the most the common battery to find on the end of life market. That is for conversion of electric or from ICE vehicles, classic vehicles to EVs, to boats and others. It's a quite good module to work with, just like Nissan Leaf is. So that became very popular for that. And so the price really spiked for many years. So today it's slower. But then you have also all these batteries that remain with the car dismantlers, where they still hope to be able to sell this when the warranty is out, when there is actually a need for batteries. That might mean that they might sell some batteries for like $500 a kilowatt hour, but behind that battery, there are many batteries that maybe never will be sold.
So they are not taking them to, even if they can't find anybody to buy them, they're not taking them to landfill. They're still sitting because they think they do contain these materials.
Yes, I mean, they are not going anywhere else because they are valuable, not because anything else.
So for completeness, let's come back to module level or cell level recycle, or reuse, because even if you can't put it in another car, you can't connect it to the grid, you can't do an old-timer conversion, and it might sit in your warehouse, or you might be able to reuse some modules or some cells. Does that happen?
All of that, again, is happening, and it also depends on how did this battery reach the end of life, what has actually happened with it. I think in the beginning, we saw a lot of module reuse. Today, those companies that has been most successful in actually building more, stationary energy storage in some kind of often containerized, they are more and more using packs, which obviously make a lot of sense. I mean, you can basically reuse everything in terms of BMS and the connectors and
packs and BMS. I need to interrupt. We have a kind of a rule against too many acronyms. So BMS is the battery management system.
Correct.
Right? So that's the whole pack. That's the assembled battery with the software.
They are building containers which look like a morgue, or almost, where you can also replace batteries when if they presumably someday would die.
It's the equivalent of a server farm. So you can pull out one rack, you can replace it.
Maybe a nicer type of
a battery morgue. They're not dead yet. They're not dead.
No, exactly.
To use a Monty Python phrase. Yes. Okay. And so there are people, but there are also people looking at the cell level to identify cells that are still good. So what you were doing 16 years ago using AI to identify, there are now people looking at cells, testing them, and then identifying the ones that really have reached end of life and ones that actually could be made up into new modules.
Yes, and there you would say people claiming that that will never be feasible. There's too much labor going into that, but this is the oldest type of reuse of lithium-ion batteries. So if you look at the value, for instance, of laptop batteries, how when we had our more bulky laptops, in those batteries you had 6 or 9 18650, look like these kind of batteries we are putting in toys.
The jelly rolls.
Yes, exactly. Yeah. Which is the same you have in a Tesla Model S as well. But it looks like ordinary batteries essentially. So if you break those packs up, I think most people look at the laptop battery and things like some kind of gel inside or whatever, right?
A unit, one unit.
Yeah,
right,
exactly.
But it's not.
No. Well, actually today more in the pouch cells, but it used not to be that. So it was like 6 or 9 cells inside. If you broke them up, that is basically all the batteries we have in our power banks are coming from those kind of packs. So they are usually reused. And you have an industry in China primarily in China, that are really doing that. But I just have to add there that also today in China, you have module reuse, because almost all recyclers in China, and that is really where the recycling is happening, they have a layer of assessment and reuse. So they would always start to assess the batteries for reuse and do a lot of harvesting of the cells, and are building them, actually themselves are building these applications for scooter packs, for can be power, like a mobile power instead of a generator. It can be obviously also residential energy storage systems.
And scooters, of course, in Asia, there's hundreds of millions of scooters, and they pull the batteries out at the end of the day, plug them in, and bring them back the next morning charged to the scooter. So some of those cells might have been in another application beforehand.
Yeah, now they are really doing it industrialized. I mean, the first activity I was describing was maybe not always great. And of course, I mean, we are talking about serious things here, because we have a lot of fires in terms of like scooter batteries and e-bike batteries. And I don't know, but I'm pretty sure that we can trace some back to not the best behavior. But I mean, today we have, not least from EVs, we actually have cell use and going into this in a very industrial way.
So if we recap, what we've done is we've sort of mapped from the source all the way to the sea,
right? Yes.
The flow of these batteries, because from where they're made, we looked at recovery, capture. What is it? The collection rate, recycling rate, etc., etc. But then once they're in that system, they don't all go straight to the grinding machine or to the electrothermal, to be melted down. No. Just can you give us an idea of how valuable, if just kind of dollars per ton, give us a rule of thumb, any numbers at any point in that kind of come, what are the key numbers that will, I think, emphasize to the audience that this stuff is not going to be thrown away because it's valuable? How valuable is it?
Yeah, today, this is obviously something that is changing, which is also interesting with these 5% numbers, how something becomes cemented. This is never fixated or cemented. This is always very plastic and always moves. But if we look at today's material prices, NMC batteries or the nickel, manganese, cobalt batteries, which are what is in most of the Western electric vehicles, they can be around, in terms of recoverable materials, around $7,000 to $10,000 per ton of battery. LFP battery, which is a lithium-ion phosphate batteries that are known to not be as valuable, are around 2,000 to maybe 3,000, depending on, obviously which day it is and which elements that are recoverable for a single recycler.
Okay, so NMC, that's nickel, manganese, cobalt, right. 10,000, 7 to 10. And the LFP, which is lithium-ion phosphate, right. Would be 2,000, 3,000, something like that. Okay.
Yes, but only 1 year ago, this was the lithium-ion phosphate batteries were essentially more worth or than what the NMC battery was 1 year before that. And then we have
it's a market, and there's some volatility based on who's buying to repurpose for what and so on.
Yes, and interesting also when we talk about this 5% number that is so old and basically contain portable batteries. That was LCO batteries, lithium cobalt oxide batteries, and they are worth like 20,000 per ton.
20,000 per ton. So that stuff that you see in the supermarket and in the DIY machine tools store, it's 20.
Not really those, but mobile phones.
Mobile phones. I see. Okay.
And laptops.
And what is black matter, and how valuable is that?
So black mass is one way to make an intermediary product out of the battery. So what you do when you actually recycle something is that you will in some way dismantle or disassembly the battery pack. That can also depend on what kind of process you are using, how much of that you need to do. And then you need to turn this into a material that is workable in one sense. One way to do that is basically, as you call it, to grind it, to shred the material. And what you will end up with is that you will remove all the organics in some way, usually by applying heat to it. You would screen out copper, screen out aluminium and steel, and then you will end up with a mix of what we call the active materials. So it's from the cathode, where you have most of the valuable materials, lithium, nickel, cobalt, manganese, if it's that kind of battery. And you will end up with graphites that come from the anode. That is all in one mix. And with that, you can't do anything. That is just an intermediary product that will now be used in a hydrometallurgical treatment.
When you say you can't do anything with it, it's not a precursor. You can't make anything directly from it. You need to process it further to extract those valuable components, right? Just to be clear.
Exactly. You can. It's not the product. You could also use another pathway, and that would be to melt it. And to melt, and not only melt it, because you would also be able to evaporize some of the material. So that would also be a way to create an intermediate product, and also then can be crushed and further used and extracted in a hydrometallurgical process.
And is it fanciful to think that we could disassemble batteries so we can actually use, sort of separate out the layers so they don't have to, because, I'm sorry, but black mass, that's I'm trying to think about Gibbs function and how far down the energy how much energy it then requires to separate things out and purify. Could we dream of disassembling batteries, or is that fanciful?
That is done today. It's done in two ways. One way is that in China, and I will just be careful here, because some people, when they think about China, they are thinking about very rudimentary, low tech. That we used to, right?
Labor,
yeah, exactly.
Family factories full of people. That's not what you see, is it?
No, definitely. But there is still that element in that you can have manual labor, right? So especially for production scrap, where you have because you have the cathode, you have the anode, and then you have the electrolyte that goes into that. But often the production scrap, they did not have the electrolyte. So you would basically have people that are doing exactly what you're saying, tearing it's like opening, what would you call it? It's like in this jelly roll, it will be a long, it's like a...
So the jelly roll, just for those who are listening who don't know what we're talking about, this is a round battery that looks like, and you're saying that they're opening just like a kind of a roll of Kodak film.
Yes.
They're opening it up like
exactly.
that.
Yes. Yeah.
Wow.
And that would be the same also from a prismatic or square battery as well. So they open it. So now you end up here with only the cathode and only the anode, right? So obviously you will get much higher recovery rates by doing that.
But you would still reprocess them. You would never be able to kind of stick them back together, new electrolyte. They're not going to be clean enough or have physical integrity.
Yeah,
surely.
So that's also interesting. So if we just finish on the actual physical aspect of it, I think now because a trend is that the cells become bigger and bigger. Mm-hmm. So, if you take these BYD blade batteries, for instance, they're like a meter long. So that lends itself a bit to actually develop processes where you, by robots, also could do that. But what we are also seeing, and that is a little bit of a trend, not least in research, that we would do what we call direct recycling, that you would not turn like the nickel and the cobalt to nickel and cobalt sulfate, which then could go back to the process. So instead, you keep the actual cathode. And I was in China only a couple of weeks ago, so one process where they actually did this, where they are applying just a thermal process, and they basically keep it. Even in the marketplace in China, you even have a price for reused cathode material.
So the engineer in me likes not sort of turning it into a lower value chemical and then have to re-purify it. I just want to cover one other topic right now, because we've reached the point where we understand this flow from the source of the materials through the different routes that they can follow. Only one of that route at the moment ends up in a recycling factory, right? There's lots of other. We talked about reuse. We talked about things. First of all, in a sense, reaching the end of their life, but it's not really the end of their life, and it gets reused as it is, or it gets reused in a different purpose. Then it can get reused at the pack level, module level, whatever. So not that much is reaching the little the bit of the flow that gets to a recycling plant. So how many recycling plants have been built, and how many of them are actually struggling to get batteries?
Yeah, there have been many more. Let's put it this way. Depending on where we are, of course, there are obviously different number of battery plants. We have had a situation where we in Europe at some point had overcapacity, then we almost had like undercapacity, was not able to process the batteries we were generating, and now we are going towards real overcapacity. The same thing in the US, and China has been in overcapacity for more than 6 years. So we are tracking about 300 battery plants that either are in operation today or are to be built. And if you would get some numbers, it's like today we have a capacity globally of more than 2 million tons of process capacity for batteries, to material recovery capacity. And we have a bit more on pre-processing, that is making black mass or something else. And if we look at the amounts of batteries that we are recycling today, is including production scrap, it's only about 700,000 tons. So we have a huge overcapacity in that sense. The interesting thing is that the investments that are going in right now is incredible everywhere, including China. So they are going towards capacity right now. Or in 2030, around 9 million tons. So much more.
So just to clarify, the 2 million that you talked about, that's recovered material. That's sort of the back end of the recovery.
That's the intake.
Intake.
Yes.
Intake.
Yeah.
Okay. So that's after you strip out the organics, or I'm just trying to get that, because are we
cell level? So
at the cell level.
Yeah.
Okay. So what you're talking about then is at the cell level. I mean, I'm doing maths in my head here. 700,000 tons over 2 million capacity is about a third. I mean, mental arithmetic's pretty good here, right?
Yeah.
So we're talking about 33% capacity utilization and still vast investments going into recycling capacity.
Yeah, because this is before many of the Western capacity is not really been built, right? Because both in the US and in Europe, we have plans for pretty big plants. And they are needed, at least some of them are needed. The problem with recycling is that you don't own the material. So you have to purchase material, and the price of what you can sell the material of is basically, it's based on the same parameters in both ends. And there is a cap. So you can only sell it to market value. So you really make money when you're buying the material. That's where the whole thing comes in. And a mine, if you have low material prices, I mean, they could say, okay, now we are not mining. Or if there are high prices, we can just dig deeper, essentially, or put more production.
Run 3 shifts.
Yes, but in this case, you can only recycle what is really there to recycle. So what we have in China is very low margins that used in some cases to be quite high, but the market is essentially killing itself by just putting more and more capacity, which is not always a bad thing, or is not so disastrous as it may sound, because many of these plants are precursor plants. They are cathode producers. So the end product is cathode or precursor. So either they are sourcing that through virgin materials or through recycling or recycled materials. If there is no opportunity on the recycling market, well, then they just have to go with their ordinary contracts. So they will always be able to sell precursor and cathode. But if you're a recycler that, your idea is really to take in recycled material and sell a product out of recycled materials, That's
So what you're saying, some of these recyclers are actually just battery materials companies. They happen to bring in used material because when it's cheaper.
yes.
But the ones that are just recyclers, they're between a rock and a hard place, because the more of them there are, the more they bid up the price of the raw material.
Exactly.
And they don't control the price of their end product. So, I mean, that's an interesting question and perhaps an interesting point to end on. I mean, would you invest? You're an information provider. I was an information provider in renewable energy. And I watched these incredible cycles, and I was very happy I was an information provider. Are you happy you're an information provider, or would you rather be an investor in recycling capacity right now?
I think overall that between, as I started with, between the point from when a battery is placed on the market and to when it goes back and is a recycled material again, there are so many opportunities in that whole life cycle, including what will happen with the electric vehicles, what will happen with the batteries, and how they finally will be taken care of and being recycled. The actual recycling market is in the very end of that. Of course, there is a service component to it that you have to serve for recalls or from production and scrap, but it is still limited. And there's also incentives for the generator of that scrap to not generate it, because it would be best if it didn't. So I think there are enormous opportunities in the whole circular value chain. I think there is a huge need for really good recycling capacity. I think there is a need for these kind of circular solutions, but they really have to, they really have to design very clever models in terms of how they are sourcing the material, obviously what kind of pricing on the end products and so forth. To believe that this is going out there as a gold miner and just say that, there is a lot of batteries, there's a mountain of waste, and say we have to have a recycling plant, which is fueled quite a lot by also regional development from China to US and Europe, that everybody needs their recycling plant. I think that is a very tricky market. I think it's a dangerous market for sure. But I definitely think that some of the companies out there today will be successful, but it will be at the expense of others.
Very good. Well, that's a fantastic summary. I think if I'm going to paraphrase it, some are going to be very successful, but they're all going to need your information.
Right. Okay. Yeah, that sounds great.
And Eric, thank you so much for joining us here today.
Thanks a lot.
I found it fascinating.
Super. Very good. Thank you.
So that was Hans-Eric Melin, founder and managing director of Circular Energy Storage. I must say, I found that absolutely fascinating, and I hope you did too. As always, we'll put a link in the show notes to some useful resources. That's the company website for Circular Energy Storage, some papers authored or co-authored by Hans-Eric, and a piece he wrote documenting the origin of the 5% recycling myth. Please make sure that you subscribe to Cleaning Up on YouTube or your favorite podcast platform. And if you've enjoyed this episode, make sure you give it a like or a thumbs up. That really helps other people find it. Follow us on Twitter, LinkedIn, or Instagram, and also subscribe to our free newsletter on cleaninguppod.substack.com. That's cleaninguppod.substack.com. Cleaning Up is brought to you by Liebreich Associates, Gilardini Foundation, and Ecopragma Capital.